Hello my friends, and welcome to my channel and to this video. My name's Jody, and whether you're a first timer or a lifer, which I hope you'll all become, welcome, and I hope you'll subscribe before we leave. Now today I'm going to be talking to you about exponential equations, which are equations such as these two, which have numbers in their bases, or numbers as their bases, and x's in the exponents. So without further ado, let's get into it. In order to solve these equations, we're going to use something that's very handy and useful in many situations, including logarithms, which will be another video. But basically what it says is that if parts of two equations are equal and there's an equal sign between, then the other parts must also be equal. So for example, in this number one here, the sevens are already equal. So since they're equal, then that means we can ignore them and set the powers equal to each other. So how many times can I say equal? So what you can casually do is say you're going to drop the base. Now mathematically, you're not really like making it vaporize, but more just ignoring it. I'd play the Skrillex clip, drop the base, but I'd probably get copyright stricken, so maybe just imagine that. But okay, so since these bases are equal, we're going to set these powers equal. 3x minus 4 is equal to 6 minus 2x. And now it's turned into a pretty straightforward little equation. So let's just solve that out really quick. Add 2x to both sides so the x's are on the left. Then we can add 4 to both sides so the numbers are on the right. You can do that in 2 steps if you want as well. But you're basically going to have 5x equals 10, divide both sides by 5, and so your final answer is just x equals 2. So once your bases are the same, it's pretty straightforward, but most questions you're going to be given, the bases aren't going to be just straightforward right out of the gate the same, so you're going to have to do a little bit of work, and that's what we're going to do on this one. So my tip for these is if you aren't sure what to make your bases become or you're not sure how to do it, do factor trees. So let's do a factor tree on 125, break that down as far as we can go. Since it's all 5s, hopefully we can break down 25 to where it's base 5s as well. Great English self. But anyway, it will be like that. So we're going to use this information to rewrite our numbers. Instead of 125, we're going to write 5 cubed. Now that is still raised to this negative 3x here. So we'll put it on the outside like that. To rewrite the 25, that would turn into 5 squared. And again, the negative 3x minus 2 is still going to be the exponent here. Like that. So now you can see that both sides have a base of 5, so we're going to be able to drop the base or just ignore it. But what you can do first to simplify these powers is you're going to multiply them. So 3 times 3x, we're going to have 5 to the negative 9x. And then to multiply these, it's 2 times negative 3x minus 2. So we will distribute that through. So that's just going to be 5 raised to the negative 6x minus 4. Now you can do that distribution after you cancel the bases, but basically, hey, we have 5 to something equals 5 to something. Therefore, the somethings must be equivalent. So we're going to drop those bases, and I'm going to come up here. So now we have negative 9x equals negative 6x minus 4. Just like that. So now let's add the 6x so that the x's are on the same side. And just finish her out real quick. And then divide by negative 3. So your final solution would be 4/3. All right, so that's the basic premise, is make your bases the same by using factor trees to break them down, and then drop your base and continue from there. So let's do a couple more examples. This one's going to throw in a really fun element in that this one is a fraction. So we're going to start by breaking the bases down. Now something I want to mention about this one is, although you can break down 81 into base of 9, and that'll work beautifully, I want to show you what would happen if we went even further with the bases, because it doesn't matter what they are as long as they're the same. So if you don't know where to start with the factor trees. So I'm going to break down the 9 and the 81 all the way to the end, and you see that they're all base 3. So now let's rewrite the 9 as 3 squared, and then that's raised to the 3x minus 10 now. Now on this side, we need to write 1 over 3 to the 4th, and we still have that x minus 2 there. So keep these powers here. Don't lose track of them. Now, they look pretty close, right? They both have a base 4. The problem is this one is not a fraction and this one is. So they don't really match this. For these to be the same, they also have to be on the same level of the fraction on each side. This is technically 3 squared over 1. This is 1 over 3 to the 4th. So this is where we want to make use of negative exponents. So we need to force this guy to move to the top of the fraction. All that's going to do is make his power negative. So we'll rewrite both sides of the equation, but that will turn into 3 to the negative 4. Just like that. So now we can multiply those exponents through and drop our bases. I'm going to kind of do that simultaneously on this one. So we're going to do 2 times 3x minus 10. And we're going to do negative 4 times x minus 2. So when I drop my 3's off, I'm going to have 6x minus 20. If I can do an arrow, 6x minus 20 is equal to negative 4x plus 8. Then we just solve it through. So I'm going to add 4x to both sides, and then add 20. Again, go as slow as you want to solve these. So now we have 10x equals 28. Divide by 10. X equals 28 tenths. Now all we want to do is just reduce that. We can divide both of those by 2. So our final solution is just 14 fifths. So negative exponents are really prevalent when it comes to exponential equations, and that can be a whole other topic in and of itself. Let me know down below if you want me to make a video on negative exponents. But I hope that makes sense. Let's do a couple more. Notice on this one that it looks a little different than the previous two because I only really have one term that has an exponent here with our x. So in this case, what we want to do is actually get this portion, this exponential portion alone first, and then we can do the same process that we did before. So what that encompasses is that we need to add 2 to both sides and then divide by 16, and then we can follow the process. Again, our goal is to get it to be this if possible. Same base to where we can drop the base and then set the powers equal to each other. So let's add the 2 first, like I said. And then we'll have 16 times 4 to the x minus 5 equals 256. Now, real quick, some people might think you can multiply the 16 and the 4 right here, and that would not be correct because with order of operations, exponents come first. And since we can't solve 4 to the x minus 5, we can't then just do 4 times 16. So instead of doing that, we will divide both sides by 16, and then we're not breaking any rules. No math jail. That is much cleaner to do it like that, and much more legal. So 4 to the x minus 5 is now equal to 16. So now we can work on making our bases the same. Now with 16, note that we can just keep it as base 4. Could we go all the way down to base 2? Absolutely, because that would work on this side. We're just going to stick with the 4's. So now we have 4 to the x minus 5 equals 4 squared. We can drop those bases and then just finish solving from there. X minus 5 equals 2, add 5 to both sides. Sorry if you can hear my dogs walking around. I think I might mention them in every video, but they're always right here under my feet. So with all that said, x equals 7 is our final solution. So if you have an equation where you have bases and powers on both sides, try to get those to where the bases are the same, and you can just drop your base, set the powers equal. Or if you have any equation like this, where you only have one part with the exponential, get it alone and then break your bases down. So let me give you a few practice on your own problems. I changed the angle a little bit so that I could write up more problems. Now, here's how I love to do these. I want you guys to pause the video right now, pause, try these, and then I'm gonna cut the video, and when I come back, I will have done all of them for you. So pause the video so you don't get a sneak peek on how to do them or what the answers are. When you come back, you'll be able to see. This is the best way to see if you're actually understanding this process. So give it a go, good luck, and I'll see you in a split second. How did you guys do? Here's all the work. I'm underestimated how much room I would need, so we drew some arrows and just go with that. But hopefully you can see where everything went and where I got everything. Let me know if you have any questions down below. I hope they made sense. Let me know if you have anything else in relation to this topic that you'd like me to cover. But in the meantime, thank you so much for joining me. I really hope you'll subscribe to my channel. I have a few other videos and I have many, many more in mind that I want to make. Have a beautiful, beautiful day wherever you are, and I hope to see you next time. Bye.